right, guys, today we're going to be talking about equations that have 1, infinite, and 0 solutions. So yesterday we focused on 1 solution equations. Now we're going to look at some unique cases. If you're writing these notes on a scrap sheet of paper or a line sheet of paper, make sure that you put this title up there along with your name and today's date. So let's go ahead and get started. We have some examples up here that I want to zoom in on, both being kind of unique. So let's check out this first one. Hopefully when you're solving this, you would recognize that you need to first use the distributive property. So let's go ahead and do that. Now, if you look, we've got x's on both sides of our equation, so we need to move 1 to the other side. Well, as you can see, they're the same. Doesn't matter which one you use. Bring down what's left over. And you'll notice a couple of things. I want you to pause the video for a second and try to recognize things that you notice about that equation. Hopefully you were able to see, first of all, that the x's canceled. Second thing you should notice is something about this equality statement. Is it true? Of course not. 12 does not equal 11 in this world. So in this case, that means that there is no number that we can plug in for x, nothing we can plug in here that would make this equation balanced. No value for x would satisfy this equation. You could try plugging in -19, 1041, 0. Nothing is going to be able to plug in for x to make that equation true. So if that's the case, if nothing can be plugged in for x, what do y'all think the solution is? Hopefully you're thinking there is no solution. So you can either write no solution or you can write empty set. So key ideas. If the x's cancel, oops, I didn't mean to erase that. If the x's cancel and you get a not true equality statement at the end or an inequality statement, that means that there is no solution. Okay, let's take a look at this one to the right. Go ahead and start solving that one on your own. Pause the screen if you need to. Now, when you get to this point, you'll notice something unique about the equation. You might notice that they're mirror images of each other. You might notice, oh, I can move the x's to the other side. And now, this one is looking similar to the problem before. And that, what happened to our x's? Well, they both canceled out. So again, we had the x's cancel. However, when we got to the end of this problem, does 5 equal 5? Well, of course, it is a true statement at the end. What does this mean? Well, this means that you can plug in any value you want for x here. Anything could be plugged into that x, and it would make a true equation, true equality statement. So, any number satisfies the equation. You could plug in 19, you could plug in -42, you could plug in 0. It's all going to balance out in the end. So if that's the case, if you can plug in any number, the actual solution is what we would say infinite solutions. Or, if you don't want to write this word infinite, the math symbol for that is infinite solutions. Either one. Those are our two unique cases. We have, sorry, if we want to highlight the key ideas here. If the x's cancel and you have a true statement, it is infinite solutions. Ba-ba-da-da. Those are the two things we're going to be talking about today. Remember, we still have our cases like yesterday where you can have one solution. That's when the x's don't cancel and you still have to solve for x. So let's go through a couple more of these and figure out if there's one, none, or infinite solutions. Go ahead and pause the screen, write that equation down, and try giving it a shot. I'll work through it on my screen. You can check back once you've solved it on your own. Hopefully when you got to the end of this first equation, you could either recognize that at this step, when you had mirror image equations on mirror image expressions on either side, or you could have canceled out the x's and gotten this true statement. This is a case of infinite solutions, meaning you can plug in any value for that variable b, and you will have a true statement. Swivel on over to the right, write that equation down. Pause the screen if you need to. When you get to the end of this one, you get a not true equality statement. Hopefully you're thinking in your head, well, those w's canceled out. That equation is not true, so this is no solution, or you can write no solution. No value can be plugged in. Go ahead and flip it over to the back if you printed this off. If you didn't, go ahead and we'll continue on. You can pause the screen here. We're going to work through a few of these examples. I want you to try this first one here. Sorry. Go ahead and try it on your own, and we'll come back together and talk about it once you've unpaused. When you're looking at this equation, you'll notice that our x's are actually different from one another. I'm going to move the smaller x so that I can deal with positive x's only. I'm going to move that x by adding 6x to the right side. Now we have 4 equals 12x minus 32. In this case, our x's did not cancel, so we'll continue solving. We were able to solve for x to get x equals 3. This is a case where we have one solution to our problem. Only one value can be plugged in for x to make that equation balanced, and that value for x is 3. 3 is the only thing we could plug in to both of those places to make the equation balanced. Let's check out the one to the right. When you have this negative out in front, you can imagine that you're just changing the sign of everything inside, or you can imagine it's like multiplying by -1. There's an assumed -1 there. Make sure you're distributing it to both terms inside, as well as on the right side of the equation. Now, hopefully you're able to see, oh, my x's are going to cancel because they're exactly the same. We subtract the 2x, move it on over, carry down what's left over. Is this true? Absolutely not. Another case of no solution. I want you to pause the screen and try out these next two equations. I'll give you the answer to those in just a minute. In this first one, after distributing the 1/3, a third of 12, or you can stick the 12 over 1 if you need to. 12 over 3 is equal to 4x minus 1 equals negative 4x plus 7. You can solve that equation, and eventually you should have gotten x equals 1. On the right side, you should have multiplied this left side by 3, multiplied the right side by 3. Now, one thing I want to point out, when you multiply this right side by 3, all the x plus 7 gets multiplied by 3. On the left side, the 3's will cancel, so we have 3x plus 4 equals 3x plus 21. We have matching x's. They're going to cancel out. You get 4 equals 21. That is not true, so you should have had another case of no solution. Try the next two, freeze your screen, and please give those a shot on your own. On this one on the left, we have fractions. Again, don't be scared of fractions. They're just fine. You just need to figure out how to clear that denominator. So if you look at our denominators, 8 and 4, try to think of the smallest number that both 8 and 4 fit into. 8 and 4 both fit into 8. So we're going to multiply the entire equation by 8. Notice how I said entire equation, not just one of the numbers, not just the fractions, the entire equation, because we have to keep it balanced. 8 times 3/8 gives us 3x. 8 times 1/4 gives us 8 over 4, which is 2. Equals 24x plus 16. Move your x's over. Move your constant. I'm going to move this over. We have negative 14 equals 21x. Divide by 21 and simplify your fraction. 7 goes into both 14 and 21, so you get negative 2/3 as your equation. Solution. I'm not going to go through the entirety of the one to the right, but you should have, once you did it on your own, gotten that negative 12 equals 12 at the very end. That is not true, so you should have no solution to that last problem. I want you to pause the screen and try out these problems at the bottom. I want you to write an equation of your creation with each of the following solutions. Try to make the equations multi-step. So I want you to try to create an equation that has one solution. Oh my goodness, sorry. One solution, no solutions, and then infinite solutions. You cannot use the equations that have been written up before there. Go ahead and give that a shot. When you log into Schoology, you'll see your homework on practicing this stuff. I wanted to show it to you, but also go through how many of each style you should have. So you're going to solve the equations. In the end, you should have 5 that are infinite solutions, 4 that will be no solution, and 6 that are one solution. So make sure that you're turning in those notes via PDF and then solving the homework as well, and uploading that homework as a PDF in a separate assignment. Those can all be found in Schoology. Thanks, y'all. Email me if you have questions, and we'll always be going over any homework or questions you have, homework questions or notes questions you have at the end of class.